we're going to learn the third method of solving systems of equations, and your target is I can solve a system of equations using elimination. Please hit pause and do the 3 warm-ups. Okay, now that you've seen them, please check your warm-ups. And now we're going to look at a problem that has vertical addition instead of horizontal like in the warm-ups. So if I were to add these up, 3x plus 6x, I get 9x. Negative 4 plus 4y is just 0, so I don't need to write anything. Negative 5 plus 7 is plus 2. So I could condense that and write that as 9x plus 2. Well, we're going to be solving equations this way. I have 7 steps here that should make it a little bit easier. The first thing you need to do, we're going to do number 1 with it, is write each equation in standard form, which remember is ax plus by equals c. I always like to think xy equals, they're all lined up, including the equal signs. My x's are lined up, my y's are lined up, my equal signs are lined up, we're good to go. Now the second step, multiply one or both of the equations so that one variable can be eliminated. Make them opposites, one positive and one negative. So I'm looking for numbers like negative 3 and 3, only in front of a variable, maybe negative 3x and positive 3x, negative 4x and positive 4x. So let's take a look at number 1. Do we see any? Look at your y's. You have opposite y values, negative 4 and 4. So step 3, so we don't have to do any multiplication, says add. You need to put your plus sign and draw your line because we're adding them vertically. 3x plus x is 4x. Negative 4y plus 4y is 0, so it was eliminated. Bring your equal sign straight down. 10 plus negative 2 is 8. Oh, now step 4, solve for one variable. Now it's easy. Divide by 4 and you get x equals 2. But remember, every answer is an ordered pair. So we have our x, which is 2, and now we need our y. So to find it, we do step 5. It says substitute your solution to step 4 into one of the original typed equations and solve for your other variable. So let's do, I think the second one's easier. So 2 plus 4y equals negative 2. So I'm going to subtract 2 from both sides to get 4y equals negative 4. Divide by 4, and y equals negative 1. So your final step is to write it as an ordered pair. And you remember, you can always go back and check by substituting it in. Let's do another one. Oh, look here. I don't have opposites, and they're not in standard form. So the first thing I'm going to do is I'm going to rewrite the entire system, putting them in standard form. So I need to use the commutative property and rewrite this as positive 3x plus y equals negative 2. Then negative 3x plus 2y, that's already in standard form, equals 14. So again, make sure you put it in ax plus by equals c. It has to be in that first, otherwise it doesn't work. Oh, look it, we have opposite x values. So now we can plus and draw your line. Negative 3x plus positive 3x is 0. They're eliminated. Positive y plus 2y is 3y equals negative 2 plus 14 is 12. Keep on going. We got a nice little equation to get y equals 4. So then take a look. Which one of the original typed equations do you want to substitute it in? I'm going to do the first this time because I did the second one last time. So 4 plus 3x equals negative 2. Subtract 4 to get 3x equals negative 6. Divide both sides by 3, x equals negative 2. So your answer is negative 2, comma, 4 as an ordered pair in your box in it. Again, remember, always go back and check. Number 3. Go ahead and look at number 3. I believe number 3 is actually correct in your notes, so don't worry about switching it. You're good to go. First thing, standard form. This time your first equation is in standard form, but your second one isn't. So I need to get the x on the other side. So I'm going to add my 5x and rewrite my entire system. X minus 2y equals negative 19. 5x plus 2y equals positive 1. So now we have opposite y's. Add them, draw your line. X plus 5x is 6x. Negative 2 plus 2y, 0, equals negative 18. Divide by 6, and you get x equals negative 3. Substitute it into one of your original. I'm going to substitute it into my second equation. 2y equals negative 5 times negative 3 plus 1. 2y equals positive 15 plus 1, which is 16. Divide by 2, and you get y equals 8. So your final answer is negative 3, 8. The next one, go ahead, try it on your own. Hit pause. Okay, so when you did all the work, you should have ended up with 2, 3. They were already in standard form. You added them up, solve for x, substitute in, solve for y, and got a final answer of 2, 3. Well, now let's take a look at number 5. I don't have any opposites here, so now we're going to have to do that middle step. Multiply one or both of the equations so that the variable can be eliminated. So I'm going to look at number 5. I'm going to say, if I added these up, 2x plus 2x is 4x. Y plus negative 5y is negative 4y equals 12. Nothing was eliminated. So don't you just wish that that 2 was a negative 2? Well, you can make it that. Remember the golden rule of algebra? What you do to the left, you have to do to the right. So I'm going to multiply the left by negative 1 and the right by negative 1. And when I do that, I get negative 2x minus y equals positive 5. I'm going to rewrite my second equation, 2x minus 5y equals 13. And now it's just normal. They're eliminated. Negative 6y equals 18. Divide by negative 6. You get y equals negative 3. Let's sub it back in. 2x plus negative 3 is the same thing as minus 3 equals negative 5. So I add my 3 to both sides. 2x equals negative 2. Divide by 2, and you get x equals negative 1. Negative 1, negative 3. And you can always go back and check. Okay, go ahead and we're going to skip this warm up for right now, and we're just going to keep on moving on by elimination. Again, don't you just wish one of the 2's was negative for the y's? Well, let's multiply by negative 1 again. So you'd have negative x minus 2y equals negative 2. Positive 2x plus 2y equals positive 8. Add them together and you get x, they cancel, equals 6. That one worked out really nice. So let's substitute it in. 6 plus 2y equals 2. Subtract 6 from both sides and you get 2y equals negative 4. Divide both sides by 2 and you get x equals negative 2. So your final answer is negative 2, 6. Okay, moving on to number 6. That was just an extra one for us. For number 6, I want you to try it on your own. Okay, after you tried it on your own, you should have gotten 4, 1. I multiplied my first equation by negative 1, added, substituted in 4, 1. You could have also done the same thing to your second equation, and you would still get the exact same answer. Okay, let's look at number 7. Again, try number 7 on your own. This time, try multiplying your second equation by negative 1 instead of your first. So I did the same thing, and I distributed the negative 1 to the second, and I added, this time my x's eliminated from each other, and I solved for y and got y equals 2. I substituted in the first one, and I got negative 1, 2 for my final answer. Number 8's a little bit different, because I don't have any number that's the same. I have 2 and negative 1, I have 1 and 3, so I can't just multiply by negative 1. So I thought to myself, if I look at my x's, I have positive 2 and negative 1 as coefficients. They're already opposites. So now, why don't I just multiply the second equation by 2? And my first equation stayed the same. 2x plus y equals 3. 2 times negative x is negative 2x plus 6y equals negative 24. Add the two equations. X is eliminated. 7y equals negative 21. Divide by that 7 to get y equals negative 3. That wasn't so bad. And now again, substitute it in. Minus 3 because plus and negative. Add 3 to both sides. And you get 2x equals 6. Divide by 2 to get x equals 3 for a final answer of 3, negative 3. Number 9, let's do another one. Oh, look at my x's are opposites again. So I'm going to go ahead and multiply the top by a positive 3 because it has a coefficient of 1. If something has a coefficient of 1, it's easier to multiply. It's always easier to multiply by the variable that has a coefficient of 1. So I'm going to get 3x plus 6y equals 33. Make sure you multiply both sides. That's the common mistake. So plus my 7y equals negative 5. You want to be organized. The more organized you are, the better it will be. So add those together. They go to 0. You get 7y equals 33 plus negative 5 is going to give me 28. Divide both sides by 7. Y equals 4. So let's substitute it in. And I'm going to have x plus 2 times 4 equals 11. So x plus 8 equals 11. Subtract 8 from both sides. X equals 3. So your final answer is 3, 4. Okay, number 10, I want you to try on your own. So you should have multiplied both sides by positive 3 on the second one, because then you would have opposite x's. So then what I did is you got 0 for y. It's okay to get 0 for an answer. And then you substituted in and got 2, 0. Okay. Number 11. This time, I don't have any coefficients of 1. So I need to think to myself, which one do I want to get rid of? Do we want to get rid of our x's or do we want to get rid of our y's? I like that my x's are opposites, which means I don't have to multiply it by a negative. So I thought, what can 5 and 2 both become? They can become 10. So I'm going to multiply the first equation by 2 and the second equation by 5. You can multiply both of them. So I got negative 10x plus 4y equals 64. Positive 10x plus 15y equals 50. And I added those up. And it's the exact same process. So I get 19y equals 144. Divide both sides by 19 to get y equals 6. Same exact process. Substitute it in. I like the second equation because it doesn't have negatives. So I have 3x. No, I was right. I have 2x plus 3 times 6 equals 10. So 2x plus 18 equals 10. Subtract your 18 to get 2x equals negative 8. Divide both by 2, x equals negative 4. So your final answer is negative 4, 6. So sometimes multiply both equations. Try number 12 on your own and then hit play. This time I multiplied the top equation by 3 and the bottom equation by 2. Then I got 3, 4. Go ahead, check your work, make sure you got it right.